Hello, welcome back to the Astroimaging channel. Today's session is kind of an open session, and wow, I think it must be, there were not many RSVPs. I think it must be the last nice new moon weekend of summer for a lot of us before either school or our kids go back to school or whatever it is. But yeah, I've got my equipment set up and ready to go. But before we start just chatting on, I wanted to show off our image of the week, which belongs to Nicholas Kazillian, and unfortunately I didn't give him much warning, so he did not have a chance to either give me a blurb or anything before he was notified. But this is his image, a beautiful image of the region around Solder, as I usually call it, but you can see the Crescent Nebula up in the top right. I do not know the nebula in the bottom left, but pretty nice field. Now, if I remember correctly, this is an 8-panel H-alpha RGB mosaic, and I don't know how he assembled it, but I do not see any panels or anything like that. He did a really nice job on this, and I love these expansive mosaics of, well, anywhere in this region. Pretty much anything you point at in this region in H-alpha is going to look good, and it doesn't matter what your focal length is. I don't know if you go well, this is an 8-panel mosaic, of course, but I don't know. I feel like wide field is dangerous, because if you take a wide field image, you're going to say, oh, well, I need to see what's around it. I want to see what else, and you just keep going. And I've gotten myself stuck in these mosaics that just kind of go on and on forever. And I usually don't get to do the RGB on it, which is what he did so well. So, Nicholas Kazillian, thank you. And if you do have a chance to give us a blurb or something about it, just let me know and I'll post it. I do see a couple viewers in the thing, so if you guys have any questions, remember this is an open session, so there's no specific topic. We'll talk about whatever. I have 1 or 2 things written down, but if we want to fill some time, we can. Again, Nicholas, thanks for sharing your image. Congrats on the image of the week. And right now, I am going to take back the monitor. All right, so first thing I wanted to show you is, and you guys are getting a sneak peek of this. I kind of snuck this into a post on Cloudy Nights, but this is my work in progress right here. And stop me if you can't see my Photoshop screen, or the image on it for that matter. The Iris Nebula, and I don't know how well you can see this, but the Iris Nebula is an awesome object, and it just kind of deserves like lots of time and just doing everything right. So I was a little bit disappointed. Even John Rista pointed it out. My stars are a bit elongated in the corners. Almost looks like field rotation. But it's not, because I'm using an off-axis guider and my prism is over on the right, probably around here where my mouse pointer is, which means if it was field rotation, it would most likely be around that axis, around where my star would be. So I'm trying to troubleshoot it. I think that it's my SCT, my edge, is a little bit out of collimation, and when it's a little bit out of collimation, the focal reducer does really funny stuff, and it shows up in funny ways. I literally spent years and years and years thinking my polar alignment was always bad with my CPC 800 with the focal reducer, and then I came to find out that the focal reducer just mimicked what looked like field rotation. But this is my work in progress, and it's not a bad image so far, but I'm hoping that I can pick up enough luminance data to really do this justice, and that if I fix whatever's wrong with it, I'll be able to match the stars up. That might cause more difficulty. I'm going to have to assume that the star size might be a little bit larger in the corners if something was going on like that. But back to this, and I think you're seeing my full screen. So there we go. So there's only a few of us in the room, so it's going to make conversations a little bit tough. What I'm going to do is I am going to invite all of what you guys. I'm going to invite anybody to come into the live room if they want to and speak. You probably have an invitation showing up on your Google Plus page. And that way, if you wanted to, you can pop in here and ask your questions live if you have a mic or a video camera. But my first topic for conversation is, and I kind of came to it because of the Iris Nebula. Before I started the Iris Nebula, I had planned on shooting it only in RGB, and I thought that I was going to get a few clear nights a few nights ago, and they didn't quite materialize, so I kind of thought I was going to get more time on it than it seems like I'm going to get. So now that I have one night of RGB, about 6 hours, 12 10-minute subs each. This is with the Edge, with the focal reducer. I had to make a decision. Can I get enough RGB in that much time to get the luminance that I'm going to extract from it looking nice enough? And I just, as my days dwindle down, there's Nicholas. Let me finish my point, Nicholas, and maybe I'll give you a chance to just give some info. So I had to make a kind of a decision. Am I going to continue RGB, or am I going to switch over to luminance and try and just get a cleaner luminance channel that I can apply that RGB to? And I switched over to luminance, but the topic I'm going to kind of bring up for conversation, if it supports it, is going to be RGB versus LRGB. What are we going to think about that? But Nicholas, do you have a microphone? Do you want to give us a couple secs on your, well, I should say 5 minutes or so on your image?
Yeah, hello, Adam. Could you hear me?
I can. I'm gonna. You're a little bit quiet right now, but just try and speak up, and I think we'll be fine.
Okay, so sorry for being late. In fact, actually, it's 3 o'clock here, 3 a.m. So I'm sorry, I'm a little tired, but I will try to explain my best. Okay.
Thank you for coming.
No problem. So this image is 8-panel mosaic, and it's been made with a small refractor, William Optics Zenith Star 66. It's a very small refractor, and a Moravian G2 CCD, and each pane is combination of 7 HA and 4R, 4G, and 4B image. And for the processing, I used PixInsight and Photoshop CS6 for the mosaic. I used the photo merge.
Interesting, photo merge. I used that a while ago. Did you try doing the mosaic in PixInsight?
Yeah, I tried, but unfortunately, I don't have any success with it. I think I had to look at the one of your last video. I think I don't look at it. I don't know how to say. I think I have to work on it with mosaic on PixInsight.
Yeah, I understand. It takes some practice, or I should say, it takes a particular group of steps. But David Alt is in the room. I see he unmuted his microphone, and he's working on something to really make that a lot easier. So I think it's going to be pretty exciting what happens. David, if you wanted to say anything about that, you're welcome to. It is an open session.
Yeah, no, I wasn't going to say anything specific other than, yeah, there are definitely techniques to make it easier. The thing I've been working on is specifically an updated version of my linear fitting for Mosaic, so you can match your panels up a little bit better. Was the problem you were having with registration, or was it trying to get the panels to match in intensity so that gradient merge Mosaic worked better?
Yeah, I had a problem at the registration.
Okay, so it was the registration is the issue, yeah.
Yeah.
Yeah, for such a large Mosaic, you really probably want to do it where you actually download a synthetic star field and register everything to that. And even then, you need to limit the registration by putting in preview windows so that when you register a panel, it doesn't try to register to all the stars in the master.
Yeah, okay. Mm-hmm.
So yeah, there's a few techniques. I think I talked about most of those in the last video that we did on mosaics.
Yeah, we almost. I think that past video was that was specifically on gradient merge mosaic, and when it doesn't work, that video like really covered everything. And on the same note, if you're having trouble with registration and everything you do it doesn't work, but it's spitting it out really, really quickly, you probably have a preview box somewhere that you don't know about, and that screwed me up a few times. Ransack errors all over the place, but it tells me that immediately. So, but thank you, Nicholas, for sharing your image. Congrats, and come back anytime.
Yeah. Okay. Thank you.
Yep. By the way, William Optics Zenith Star 66. That's my old scope. It's a really nice scope.
Yes, but the focuser is not. I don't know the word, but the weight is too high for the focuser with my CCD, and I had to make something to make it more rigid.
The focuser, yes, I noticed that too. Yeah, I got a different focuser for mine. I had a Moonlight, but since then, William Optics has really improved their focusers a lot. I'm pretty surprised by the Star 71 focuser, but I don't know. In my opinion, they have to make the CCDs lighter. but thanks again.
Okay, thank you.
So going back to what I was discussing before, RGB versus LRGB, and I will let anyone in the room start before I do if they care to. I don't know. I know David's a CCD imager. David, go ahead.
Oh, sure. Also, Dylan asked a question that we can get to after this one. You know, I live in a really heavily light polluted region, and I have a lot of local light sources I have to deal with. So if I'm going to do any wideband imaging, I tend to just do RGB, because the Astrodon filters have kind of a gap built in between the red and the green that cut out a lot of the light pollution spectrum, you know, natively. So just by doing RGB, I've done a pretty good job of cutting that back. Yeah, I could use a light pollution filter as a luminance, but I found that it kind of throws the spectrum off a little bit, and I don't quite like the results. So I tend to just do straight RGB instead. You know, it's probably a personal preference at that point. You can probably get a little more signal-to-noise ratio a bit faster using a light pollution filter and RGB versus you know, just using straight RGB. But the difference in my location is not going to be great.
Yep. And it's funny how I think that when I first got, I don't know if it's a kind of a newer thing, but I always used to assume the whole thing was you take your luminance, this is just the standard, take luminance at full resolution and bin RGB, so you don't need much RGB and you don't really need the color resolution. And I don't know if that's, I don't know, I'm too new into the CCD game to know whether that's been kind of a sea change of opinion or whether that's always been that way, and I was just kind of not knowing of it. But I see a lot more people kind of advocating that RGB. RGB extract the luminance, and you take advantage of the gap. And it's funny how it is an opinion, because I think it also comes down to are you going for time? Are you trying to capture as much data in a set period of time? Maybe you're at a star party and you know you only have 2 days and you want to capture these 3 targets, and maybe you can find a way to do it faster by using the luminance. But it kind of becomes an opinion.
Yeah, there's probably a way to determine, for your given area, whether you would hit a certain signal-to-noise ratio faster doing RGB or doing light pollution RGB or LRGB, whichever combination you use. Yeah, I think if you're used to doing it a particular way, I would just keep doing it that way, right? That's how it works for you. The differences are probably going to be pretty small. They're not going to be massive differences, I don't think, between those types of setups.
Yep. And I know the PI board on the PixInsight board. I don't know if it was Juan, but I think he kind of explained it succinctly, where he said RGB is the best for a few reasons. First of all, you're getting full resolution color. It's going to match up perfectly to your luminance. And the downside of it is time. Well, if the downside of it's time, then it's kind of like the downside of something being it's expensive. It's expensive because it works, and but it takes more time. It's going to take a lot more exposure time to hit that signal-to-noise ratio you want, or to get to that noise level you want. Which is an interesting way of looking at it. I guess if you're like I said before, if you're fixed for time and you need to get it in a particular amount of time, then maybe your strategy changes a little bit. And let me see here. Dylan was asking, point him in the right direction for stacking in PixInsight. He doesn't know where to start. For beginning in PixInsight, batch pre-processing script, and let's see, I probably got it open. Here, let me show you. All right, scripts, batch pre-processing. And this is the closest, if you use Deep Sky Stacker, this is basically Deep Sky Stacker front-end, style front-end for PixInsight. I'd definitely say start using this for everything, including your, to generate your frames. You can, after you go through, so when you run this, you're going to pick your bias, your darks, your flats, your lights. You're going to pick your registration reference image. Now this is only the reference for the star alignment. This doesn't, I don't believe, become the reference image for weighting. And then you pick your output directory. And you can click diagnostics. It'll tell you if everything kind of conforms. If you have too few lights and you're trying to use a rejection algorithm that suggests a specific number of lights, it might give you a warning. PixInsight, if you're new to it, likes to give you lots of warnings, especially if you try and save something in JPEG. They really don't want you to save stuff in JPEG. Yeah, you pretty much put everything in here. If you're using a mono CCD, it will even sort your channels for you. If you're using masters, you check these boxes here. If you are scaling your dark frames, I believe it's optimized dark frames right there. you can generate your rejection maps. I guess it's good to have them if you're going to go in and do further manual processing and compare them to your initial rejection maps. Export calibration frames, and you go in and you run that, and it pretty much gives you what you need, and then you get to a folder that, let's see, you get a folder that has master, registered, and calibrated in it. And the master, that's where your frames are, your master lights. This is O3 and H alpha. You get your calibrated frames. So let's say you've gone through that process, and I guess we're getting a long intro to batch preprocessing script. Let's say you've gone through that process, and you notice either a satellite trail or something through it that you have to get rid of. Instead of having to go through the whole batch preprocessing script process, you have your calibrated frames right here. You have your calibrated and registered frames right here. So let's say you find out that the issue's in frame 13. You can use the image integration tool in Process Explorer to only integrate the frames that you want. So you don't have to go through the whole batch preprocessing script all over again. Let's see, image integration. So basically, batch preprocessing script is a script that's feeding all the information into star alignment and image integration. And once you're comfortable with it, try doing manual image integration, because for some reason you get better results out of it. I don't know why. It seems like I'm giving it all the same information, but for some reason, the manual, and John Rista just commented on this the other day. For some reason, I don't know why, but it might have to do with it. The only thing I can think of is the registration image. Maybe it's weighing the top registration image, which I get to select in this case. Yep. Yeah, which I get to select. Oh, excellent scripts, batch processing script. If that's all you wanted to know, yes. Nebula, lots of people use standard deviation to average out. Yes. Well, not necessarily. The sigma clipping, I believe, or the Windsorized sigma clipping will average out satellites. For me, I don't know if this is going to be consistent through all setups, but it takes about 13 frames or so before the satellite trails get averaged out.
The point of the standard deviation or any of the rejection algorithms is that that satellite trail is not even included in the average. It's rejected as outliers before the average occurs. Right?
Oh, okay. Okay, yeah.
That's the point of any of the standard deviation algorithms.
Oh, okay. Is there a standard deviation in PixInsight then? You can
Well, it's using the Windsorized sigma clipping, which is a form of standard deviation.
Okay.
It's a little more accurate. It's slightly different than the kappa sigma clipping and those, but it's pretty accurate.
All right. I hope that answered your question. Any other topics anyone wants to bring up? I know we're probably going to have a short session tonight. Like I said, I am hoping to get one of my last nights of imaging before my son goes back to school. Let's see. I think we did noise reduction last week, and next week I am planning on doing a presentation on the astrophysics imaging workflow. We've seen the workflow for software BISC and the sky. We're also going to have some interesting stuff on using a Mac to script for the sky coming up in the future. I'm going to schedule that shortly. But I'm going to go over the astrophysics workflow, so that way you'll get an idea if you're considering an astrophysics mount, or even if you have an astrophysics mount and you want to just learn a few things that you might not know, or maybe you know, or maybe you want to give me some hints on things that I don't know about it. But I think it'll be an informative workflow video, and you'll get to see how the mount works, and if you're considering one. Well, it was a short show. There weren't many topics. I want to thank again Nicholas for waking up at 3 a.m. to talk about his image. That's dedication.
Hey, Adam, we do have one other question that popped up. Tolga wants us to talk about full width half maximum.
Oh, and he emailed me about that, and I pretty much, yeah. David, you might be better. You might be better to answer this question than me, and I hope you can answer it. Now, I'm going to assume that it's the same question he asked me in the email. When they refer to a full width half max in a filter, what exactly are they saying?
Oh, they're talking about the actual band pass of the filter. So, you know, the filter isn't a perfect square where at a certain frequency it doesn't allow light through anymore. It's got a curve to it, and that curve typically has some sort of distribution that may be somewhat similar to a Gaussian distribution, especially for really narrow band filters. So it will have a width at half of the max of the full transmission, right? So for a filter, I think that's what they're referring to.
Okay, and he's actually, it was a little bit different of a question. I guess it was, why do smaller pixel scale images have smaller full width half max? I would have thought it would be the other way around. Okay, small.
I think that means you're measuring full width half maximum in terms of the actual pixels, not in terms of arc seconds, right? So if you actually plate solve your image and determine what your image scale is and get that full width half maximum in terms of what it is actually covering in the sky, it should be larger for, you know, as your image scale increases, the number increases, meaning that, you know, a pixel covers more of the sky.
Right.
But, you know, as that number drops, as you're oversampling more, you should be able to resolve the actual point spread function of the optical system, including the sky, better, so that value should go down, right, relative to the actual sky rather than to the pixels. Now, if you're asking about relative to the pixels, then and saying pixel scale is smaller, say you're 3 arc seconds per pixel versus half an arc second per pixel, then it just means that the point spreads, you know, function of that star is spread across more pixels, so that full width half maximum is going to be larger. Does that make sense, Tolga?
I don't see a response yet, but that makes sense to me. Yeah, if you're talking about the pixels rather than the arcsecs.
Yeah, you really have to separate exactly what you're looking at and understand, you know, how the spread of the star actually looks relative to the pixels versus relative to the sky.
Yep.
There's a little delay between us and.
Yeah, I know. I'm giving him a few seconds to comment. Yeah, I'm trying to think though. Okay, why do smaller pixel scale images have smaller full width half maximum? And I'm wondering what he's changing. Because like, are you switching telescopes? Yes, thank you. Are you switching telescopes, or are you switching cameras? Because if you're changing your pixel scale, then I guess if you're changing your camera, then you have kind of a fixed field of view.
Now, here's a good example. So I have my SVR 90T 90mm refractor, and I was using an ADIC 314E, which had 4.65 micron pixels. I just got a QSI 6120, which has 3.1 micron pixels. So my pixel scale went from like 1.6 down to 1, right? So my pixel scale decreased. So that meant that the point spread function of the star actually covers more pixels now. So that does two things. It means that I'm resolving the actual shape of the star better, so I can get a better description of it, and my actual sky relative full width half maximums in terms of arc seconds went down a little bit. You know, the best I could do before was about 2.5, but now I'm actually getting closer to 2, and sometimes a little bit below that because I'm more accurately modeling how the star actually falls across the pixels.
Mm-hmm. And that probably helps things like deconvolution as well.
Absolutely. Yeah, having the star actually spread across an appropriate number of pixels, at least 3, makes a lot of processes actually a little bit easier to deal with.
Actually, we noticed that even, well, I don't know if it's quite applicable, but with the drizzled VDB 152 data seeming to be of better, just kind of working a little bit better. Although maybe that's not quite applicable here. But all right, well, I think Tolga got his answer. One more time for throwing questions out to the room. I'm going to check back into the chat area.
I might have one.
Go ahead, Hytham.
Actually, I shouldn't say I might, but I do have one. Let me share my screen here really quick. So I'm just working on a new image. Let's just do the whole bloody full screen here. Number 1. And let's see. Do you guys see PixInsight up and running here in front of you?
Yep.
Yep.
All right, cool. So this is my latest image. So this is just a North American nebula, and I'll show you what I finished with. So this is the end result. See that the nebula is very pink. Didn't come out red. I would expect it to be a little bit more red. So I'm thinking that there's an issue when I do my background neutralization and my color calibration. And I wanted to get everyone's insight here. So this is the image prior to any neutralization or calibration done to it. And let's get rid of that. So one of the very first things I did was just do unlink so I can look for an area of background where I could select neutralization. PixInsight had suggested that you could use an area of dark nebula.
Oop, you just muted yourself. There you go.
I muted myself? How the heck did I do that?
I think so.
Oh.
No.
That's impressive. I'm not even on that screen. Anyway, all right. So I guess I may have just figured out a key combination or shortcut key to mute myself through Hangouts. Awesome. So what I was thinking of is, so the guys in PixInsight are saying that you can select an area of dark nebulosity to perform your background neutralization. So I'm looking at something like maybe in here, or
Yeah, right center of the frame, I'd say. I mean, I can't see if there's anything there, but yep. Is there any? I can't see it. Is there much like variation in that sky, or is it pretty much just black?
no, it's pretty much black. There's a little bit of variation, but what I'm hoping is that the lower and the upper limits will be stripped out. So anything that falls below the lower limit, that's then I should bump that up. Wow, that was foolish. Let me see here.
Now, Hytham, while you're doing that, is this a straight RGB image, or does it have H-alpha component added in or anything?
Straight RGB. This is only an LRGB image, no H-alpha at all added to it.
Okay.
So this is just the base RGB image that I'm starting off with. Let's see here. So we've got a lower level of around 007, 008, 006. So it looks like trip 05 is the lowest limit there. Yeah, all right, that looks good there. So apply that to the image. Son of a gun. That came out 1,000 times better already. I think that was the mistake that I made, was I forgot to set the lower limit. Oh, I'm so mad at myself. All right, well.
Just so you know, Hytham,
Yes.
in addition to that, the the spectrum that you get from a straight RGB image, whether it's a DSLR or one-shot color, they tend to be more blue in these nebulas as well because you see more of the reflection component
Yes.
relative to the H alpha. And the rest is really just how you want to push the image. You can push the the reds up more over the blues, if you choose to.
No, that makes perfect sense. That makes a lot of sense. So I think that's the mistake that I made. I forgot to set the base lower limit of the background, because that is an entirely different image now. I should show you guys what the original looks like here. So that's the other original here. Let's do side by side.
You couldn't have possibly picked the wrong target or reference image, could you? Because I do that actually more frequently than I'd like to admit. But I guess
so selecting the background preview?
Yeah, like I don't know, if you have a lot of workspaces active, then occasionally I have like preview 1 and preview 2, and
I understand.
I'll select the wrong one and it'll mess up the image, and I'm like, what's going on here? I'll do it over and over and over again and realize that was what I had wrong.
Yeah, what I end up doing is when I start having multiple windows up, so if I want to use, say, the stars as a background, I pick multiple areas and do an aggregation point, I just typically rename it to background. If I could spell, then there's no mistake. That's what I tend to do. I know I didn't do that, but I think the area of reference I selected differed. So if we were to take a look, this is the area that I use. So if you look at the window on the left, that little snake structure, I think I used that the last time there.
Yeah, there may have been a little too much H alpha still in that region, so it had a bit of a red hue to it, and that pushed the reds down when it equalized it.
That sucks. So I think that's all it may have done. So I guess the next question that I have for you guys, so when you're doing a color calibration on an image such as this, I know that if there's a lot, you can typically use the entire image. If you have a lot of reflection nebula or emission nebula and dark nebulosity, you can use the entire frame. Do you guys tend to do that at all?
I do, with structure detection, yeah.
With structure detection. So have you ever done it without structure detection?
Not for those types of images, no.
See, that's one of the other fun tips the guys at PixInsight gave as well a little while ago on one of the images. See, and I hate what it does to the color there. And I'm wondering if there's a better way of doing that, because they said in one of the row images that they had processed, and they did a video, but they didn't state why. And that's one of the things I've been racking my brain with, why that was a better way than using structure detection and just using the stars to determine or to get a proper white balance.
So they did that on row Ophiuchi?
Yep. Yeah, I wish I could find the video. It was up on the PixInsight forums a little while ago, and someone was asking, saying, in an image such as this with so much nebulosity and there's no background available, what can one do to determine A, background neutralization or proper background sample, and B, how do we go about getting color calibration? So they selected the darkest nebulosity in the image they could find. They used that to perform the background neutralization. And the second step that they did was, and the reason they stated, but they didn't go into more detail, was the fact that there was a lot of reflection nebulosity, emission nebulosity, and dark nebulosity in the image that it provided a nice white reference. And that part is confusing to me.
It may just be that particular target, because maybe the reflection colors coming out of the row happen to be closer to white, because it is, I don't know, there are colors in row that you don't see in pretty much any other reflection nebula, the oranges and the yellows, and so maybe it just happened to be that target that it happened to work on.
Yeah, I'm wondering if it's more they just had a good spread of different colors. You've got reds, you've got oranges, you've got blues and stuff all in one area, so that the aggregate of that is more of a normal white source once you kind of average it out.
So yeah, so the varying degree of wavelengths just gave them the ability to create a proper white reference.
Right, but I would imagine that's very, target specific. I wouldn't do that normally.
Not for every single one. No, because I tend to go between each of those and just looking for the right color-ish balance and hoping kind of for the best, and I'm growing tired of doing that. So it looks like that background neutralization, just changing the area reference and then upping the lower limit, helped create a color that I prefer much more. So great, I get to redo all of this.
I think they're coming out with new color calibrations in the next version. I think I saw on their post about 8.4.
Okay.
They're talking about in winter or fall they have a whole slew of new tools for doing color calibration and background neutralization and stuff like that.
And is it a new interface, like some sort of new user interface they're coming out with?
I think it's a new tool.
Oh, a new tool, just a tool?
I think it's just a new tool.
Okay.
And they were saying that they're actually moving to a lot of total generalized variation based tools, and I'm wondering if some of these are using that same base algorithm for doing that, which is very good for being highly structure independent and linear versus nonlinear independent. So they could be a lot better for some things like that.
Well, that's kind of neat.
Yeah. All
Well, that
right.
covers me.
Glad we could help.
I saw Sean pop in. Does Sean have any questions?
Sean went from not having any CCD cameras a few weeks ago to now having 2.
I know, right? That's the way to do it.
Yeah.
Good
High
times.
roller.
Yeah.
I think. I'm trying to think if I had anything else, but I think I am officially good.
Yeah, I have one question based on that. Do you guys, when you have no nebulosity for background neutralization, use the aggregator tool? Like on
preview aggregator.
Yeah, on very, very teeny pieces, or no? Do you just use the lower limits and try and like do it manually? I'm not even sure how I would set it manually.
I just use the lower limits most of the time.
You just use the lower limits.
Yeah, unless I have a specific case where, I just have tiny little pockets of background here and there, and I want to try to get the best average possible, then I'll go through the effort of drawing the preview windows around all the sections and doing the preview aggregator.
Yeah. Yeah, I don't know. I've done that a few times, and it just doesn't feel right. Like, it feels like you've got such a small sampling, but I guess they add up. And it's such a pain in the butt. All right. Well, now, I don't know if we have any other questions. Please, guys, ask your questions now, because otherwise I'm going to have to end the session soon, and we have a few people now in the room. So, as I said, next week's session, episode, or whatever we want to call it, the astrophysics imaging workflow. And in the future, we're planning lots of good stuff. We're going to hear some stuff about scripting the sky. It's specifically for Macs, but I think a lot of it will apply to PCs as well. We're going to get something on Innie's Astro Actions, which a lot of people here, I'm sure, are using. And a few other cool things planned. Josh is at a star party, so I'm sure we're going to get his report when he gets back. But otherwise, guys, I think I'm going to end it now. Thanks for coming, and we'll see you next week.